All right, so with this, we've been dealing with our optimization. We spent some time on the like for two examples, example one and two for the notes yesterday. So today we're going to continue on with more of practice, more chances to make sure we understand how to do this. So that's what we're going to do today. We're going to work on another example here for the warm up, and then we're going to work on two more later on. All right, so here it says find two positive numbers such that the sum of the first plus 5 times the second is 50, and the product is a maximum. All right, so with this, like I've said in class, your whole goal when it comes to optimization is figure out, okay, what are you trying to maximize? What are you trying to minimize? So in this case, if you look at it, you see that we're trying to maximize the product. So the product of two numbers, we're trying to find the maximum number or maximum product there. So when we actually get to our steps and everything, and we like start trying to figure out what equation to create for our step two of actually seeing what's being optimized, we always look at that part because when it comes to optimization, we're either talking about maxes or mins. We're talking about, let me go back to the slide really quick. Go back to the slide that we originally talked about when we did optimization. Remember, optimization is trying to figure out what is the largest quantity or the smallest quantity. So the largest quantity means that we are trying to find the max. If it's the smallest quantity, we're trying to find the min. So it's going to ask us, it's going to tell us to find something. It could be like area, it could be volume, it could be product. It's going to be something that you're trying to find, and it's going to tell you the max of this, the min of that. So in this case, again, every time it's going to ask you something like that when it comes to optimization. So with that, and in this case, we're trying to find the product of these two numbers. So first off, the first step we normally talk about is we draw out the situation and be able to like label the parts of it. Well, in this case, there's nothing really to draw out. All we know is, okay, we have one number. We'll say x is the first number. I think that's yeah, x is the first number. And we'll say y is your second number. So we have two different numbers. They didn't say they were the same or anything. They just said two numbers. And then that was pretty much it. So then step one, pretty much there's nothing to draw. So we just wrote out what y and what x are. So step two, now we should be able to figure out the product of that, the maximum product equation. So here, what I'm going to do, we have product, whatever that product is. Remember, product is the answer or solution to a multiplication problem. So here, if we're talking about multiplication, that's going to be our first number times our second number. So the product is x times y. Okay, so we have what we're looking for. We're looking for the product, the maximum product. We have that equation. But again, before we can actually do anything with our max and our min, and remember, max and min, we're talking about like being able to graph it out and find the highest point or the lowest point, the peak or the valley of the graph that we're looking for. So here, we're looking at this part, and if we're trying to be able to make it to an equation that we can find a peak or a valley, we know that these both have to be either both x's or they'll have to be both y's. And in this case, we like y's, we like x's better, sorry. So we're going to solve for y for whatever we can get to. So this third step said that we need to make sure that we can actually take whatever information there in the problem that's left over and make it into an equation that we can solve for y so we can get this to be x and this to be in terms of x. So something plus x, sometimes x, something with x in it. So that way we have x here, x here. All right, so with that, if we take a look at what is being said here, we can see that it says the other thing that we can find is a sum. So they give us information, they say sum. We know sum means addition, so we actually are going to add two numbers together, add something together. But with that, it says the sum of the first plus 5 times the second is 50. So for our second equation, that again we always should have two equations, or if we're trying to make it over from x and y to all x's or all y's, we need to have a second equation. That's the part that we have right here. So for 3, we're talking about the sum. So here we know that the sum, whatever that answer is, remember that's the answer to an addition problem, the sum of the first number, so the first number here is x, that's what we said right here, the first number, plus 5 times the second number. So 5 times y. Okay, and it said that is 50. So in other words, the sum equals 50. So here we should be able to put that 50 in for the sum and then actually combine everything that we need to do and solve for y. So we can do here. And at this point, we should be able to solve for y. Because again, we're trying to get the y to change over to something with x in it. So here, let's subtract x on both sides. Then we divide both sides by 5. So everything's going to be divided by 5. So we do 50 divided by 5, we get 10. This is understood 1 right there. So 1 divided by 5 is 1/5. And that equals y. All right, so here we divided by 5. And so we get y equals 10 minus 1/5 x. So what we can do now is take, let me change the color. Take this portion here, and we can substitute in for that y. So we can actually say, okay, well, y is not y anymore. Now it's 10 minus 1/5 x, because y equals 10 minus 1/5 x. So here, we're going to rewrite this equation. The product is equal to x times, and then the answer we got right down here. So that's that 10 minus 1/5 x minus, right? Okay, so with that being said here, we're going to go ahead and multiply that through so we can get an equation. But again, you can put that equation into the calculator and actually get an answer. But distribute that here. So our product equation, again, we're trying to find the max product. So we get that equation. And if you look at it, again, if we look at the front of this equation, if we were to do in descending order, just rewrite it so we're in descending order. We look at our leading coefficient, and it tells us like what's happening with our function. And as you look at it, you can see here, 1/5 is negative, a negative 1/5. So if it's a parabola, because it's x squared, that means if it's a negative in front, using our transformations that we talked about earlier, it means it's going to open down, which means we will get a max somewhere right there. And that's what we're looking for. So here, we're going to go ahead and go into Desmos. We're going to actually put that equation in and find our max. Okay, so we put this equation in, this one right here. And let me go and erase this part because we don't need that. All right, so we put the equation in there into the calculator. And again, like I said, it was going to give us a max. And with our leading coefficient there being negative, it did. So it gave us a value for x. So here, go back. Stay there. Okay. So here we go. So we have a point there. So our x value is right here. That's our x, because x and y type thing. So here, our x value is, so we're optimizing. So x equals 25. That's your maximum number. That will give us the maximum product. All right. And so here, we need to find the actual two numbers. So it says find the two positive numbers here. So we found x, we need to find what y is. And if we wanted, well, let's do that first. So if we're going to find y, which means we need to use this equation here because that's when y equals that. So here, we're going to substitute the 25 in for x and solve for y. All right, so here, that's 10 minus 5. So y equals 5. All right, so we get our two numbers of x equaling 25 and y equaling 5. And again, if you remember back, at this point right here, we said the maximum product was going to be that equation, that max point, the highest point of that equation. Well, this is the equation right here. which means this graph is the equation. So the output, this is your output. The product is your output, which means, like we said, that's our domain and range, but that's your Y value for this part. So that means our actual max product will be 125 because that's your output. That's the product that we said that we were going to get, the max product. So Y is that max product right there. Not Y, but this part right here is your product. Your max product. Okay, so that's your max product there. So we have the max product of 125. We have X is 25. We have Y is 5. That's it.